All right, ladies and gents. Today we're continuing our talk on quadratic functions. Yesterday we learned about the axis of symmetry and the max or min value. We also learned about the a and c of the standard form of a quadratic function, where a tells you if you have a positive or a negative parabola, and where C is the y-intercept, okay? So the standard form of a quadratic, the most common form you're going to be seeing this year. We learned about the parts of them. We learned how to find the max and min value yesterday. We also determined that the x-axis is the x value of that max or min point. Today, we're going to talk about solutions to quadratic functions. So the solutions to solutions to a quadratic function are where the parabola crosses the x-axis. Okay, very important. These solutions to a quadratic function are where the graph cross the x-axis, okay, represented by the point xy, okay, and where x is a number and the y is 0, okay. This represents the solutions to a quadratic function, okay. They're also called zeros, okay. Solutions or zeros, X-intercepts as well can be used to describe them. X-intercepts. So solutions, zeros, X-intercepts, all to you mean the same thing. Okay? They can also be called roots. Okay, roots. The most common ones you're going to be seeing more than anything are zeros and roots. Zeros and roots are the solution or solutions to quadratic functions. Okay? So, continuing on with solutions, there are three different types of solution groups. Okay? So, you guys, three different types of solution groups. Okay? We have one solution. Okay? One solution basically means that your parabola will sit right on the x-axis. Okay? That means you have one spot where the parabola crosses or touches the x-axis. Okay? So right here you have one solution to this positive parabola and one solution to that negative parabola. Okay? You can also have two solutions. Okay? It's basically the same thing, except now your parabola is going to cross the x-axis twice. Okay? So there are your solutions. The x-intercepts, where the parabola crosses your x-axis. Okay? Again, just another example. 2 times because it crosses over the x-axis twice. One solution where it sits on the x-axis. 2 solutions where it crosses and it hits twice. Or you can have no solutions. No solutions. No solutions means exactly what it says. There will be no point where the graph crosses the x-axis. So usually if it's just setting up out there if it's just setting up there out of nowhere where it does not cross the x-axis. It can cross the y-axis, that's fine. That's the y-intercept. But your solutions can never cross the x-axis. Well, I'm sorry. When you have no solutions, your parabola will never cross the x-axis. Okay? Not too much to solutions. If you're given a graph, they're a lot easier to identify. If you're given an equation, you're going to have to use your calculator to do a little bit of looking. But that's not difficult either. Okay? Just like you found the y-intercept, you'll find the x-intercept the same way. So menu 5-1, and then you will scroll over until it lands on one of those points where it crosses the x-axis. And it'll give it to you in a little box that says 0. Okay? All right. So let's look at some examples if you're given a graph. All right. So we've got a graph here. Let's see, move it to where you guys can see it. All right. So we've got a graph here. And what I want to do is I want to identify the zeros, how many of them there are. I want to know the y-intercept, and I want to know the axis of symmetry. Okay? So we're going to answer all these questions. We want to know the max or min value, I want to know the axis of symmetry, I want to know the y-intercept,